Hi, this is Algebra 1, Module 7, Lesson 11, the notes, throwing an interception. Here, we're going to have a bunch of proofs on how we can solve these better. So the x-intercepts of the graph of a function are often very important because they are the solution to the equation f of x equals 0. In past tasks, we have learned how to find the x-intercepts of the function by factoring, which works great for some functions but not for others. In this task, we are going to work on a process to find the x-intercepts of any quadratic function that has them. We'll start by thinking about what we already know about a few specific quadratic functions and then use what we know to generalize to all quadratic functions. So an algebraic formula with the x-intercepts. So what can you say about the graph f of x equals x squared minus 2x minus 3? Graph the function. Well, before I graph it, I wanted to put it in vertex form. So I'm going to go ahead and do my x squared minus 2x plus. So if I divide by 2 equals 1, negative 1 squared equals 1. And I'm going from 1 to negative 3. So it's x minus 1 squared minus 4. So my vertex is at 1, negative 4. And I need 5 points. So 1, 2, 3, oh, that's only 4. So 1, negative 4. And so if I put in 2, 2 minus 1 is 1 squared. 1 minus 4 is negative 3. 3 minus 1 is 2. Squared is 4. Minus 4 is 0. Oh, look at that. We got some x-intercepts even. So if I graph the function, it's negative 1, 0. It's 0, negative 3. You probably have to draw your lines in there. 1, negative 4. And then back up. All right, so we graph the function. What is the line equation of the line of symmetry? The line of symmetry is going to go right through my vertex. So x equals 1, positive 1. What is the vertex? Well, the vertex we found was at 1 comma negative 4. Now let's think specifically about these x-intercepts. What are the x-intercepts? Well, let me scroll down just a little bit. They're right here. Negative 1, 0, and 3, 0. So negative 1, 0, and 3, 0. How far are the x-intercepts from the line of symmetry? Well, it looks like they're 1, 2, so 2 units. If you knew the line of symmetry was the line x equals h, and you know how far the x-intercepts are from the line of symmetry, how would you find the actual x-intercepts? Well, we would, I'm going to go ahead and type on here. We could add or subtract 2 from from h. So the x-intercepts are h minus 2 comma 0 and h plus 2 comma 0, right? Because if our x equals 1 is our line of symmetry, 1 plus 2 is 3, 1 minus 2 is negative 1. So how far above the vertex are the x-intercepts? Well, let's see. 1, 2, 3, there are 4. 4 units above. What is the value of f of x at the intercepts? Well, my answer, f of x equals 0 at the intercepts. So in other words, f of negative 1 equals 0 and f of 3 equals 0. Okay. So just to make it a little bit easier here, to talk about some of these features that relate to the intercepts, let's name them with variables. So from now on, when we talk about the distance from the line of symmetry to either of the x-intercepts, we'll call it d. So this distance right here is d. The diagram below shows this feature. We'll always refer to the line of symmetry as x equals h. So the two x-intercepts will be at the point 8 minus d, comma 0, and h plus d, comma 0, kind of what we did up there with the 2. So let's try this with number 3. So let's think about this other function, x squared minus 6x plus 4. Let's put it into vertex form. X squared minus 6x plus, okay, so divide by 2 is negative 3 squared equals 9. So I have to go from 9 to 4. So x minus 3 squared minus 5. Okay, so that's the vertex form, which means I'm going to want to 1, 2, 3, 4, one more, 5. So I need 3 comma negative 5, which is 2, 1, 4, 5. So 4 minus 3 is 1. 1 squared is 1. 1 minus 5 is negative 4. 5 minus 3 is 2. 2 squared is 4. 4 minus 5 is negative 1. I better go one more because I want to see what these x-intercepts are. So 6 minus 3 is 3. 3 squared is 9. 9 minus 5 is 4. I might actually draw this line a little bit shorter here. So I can, wow, that is not on the line. Try that again. There we go. Okay, so let's go ahead and graph this. 0, 4, that's on my line. And 1, negative 1. 2, negative 4. 1, 2, 3, 4. 3, negative 5. Then we can start coming back up. Okay, 1, 2, 3, 4, 5, 6. Perfect. Try to be accurate on here. What is the vertex of the function? Well, we said the vertex was at 3 comma negative 5. The equation of the line of symmetry, well, that's going to go right here. So x equals 3 this time. What do you estimate the functions of the x-intercepts to be in this case? Well, I don't know. This one doesn't look very far from there. So I'm going to say 1, 2, 3, 4, 5.2. So 5.2 comma 0. And then the other one, we said it has to be equal distance. So that should be 0.8 comma 0. Okay, so that means D has to be 1, 2.2. So D is about 2.2. So what is the value of f of x at the x-intercepts? So just like we said before, f of x always equals 0 when it's at the intercepts. And so now, using vertex form of the equation and your answer to f above, write an equation and solve it to find the exact values of the x-intercepts. Well, our vertex form is x minus 3 squared minus 5, and we need that to equal 0. So I'm going to add 5 to both sides. So 5 equals x minus 3 squared. Need the square root. So the square root of 5 plus or minus equals x minus 3, which means plus 3 plus 3. So this would be x equals 3 plus or minus the square root of 5. Okay, so that's the exact because it wants the exact. This is the exact. All right. What is the exact value of D? Well, D would be the distance. So I started with 3 as my line of symmetry. So if I took 3 and I add or subtract to it, D has to equal the square root of 5. So using a calculator, we'll find the approximations for the x-intercepts. So 3 plus the square root of 5, 3 minus the square root of 5. So when I do that, 3 plus the square root of 5 is 5.23, 5.23, and we'll go all the way to 6. And then 3 minus the square root of 5 is 0.763. So how do they compare with your estimates? Well, I said 5.2 and then 0.8. So I was close. Pretty close. All right, so what about a function with a vertical stretch? Can we find exact values for the x-intercepts the same way? Okay, let's put this in vertex form. 2 parentheses x squared minus 4x plus, divide by 2 equals negative 2 squared equals 4 times 2 is 8. So I'm going from 8 to 5. So 2x minus 2 squared, 8 to 5 is a minus 3. All right. And so my vertex is at 2 comma negative 3. So again, I'm going to 3, 4, 5, 1, 2, 3, 2, negative 3. Let's see if this gets us to at least past the x-intercepts. So 3 minus 2 is 1, 1 squared is 3, minus 3 is 1 minus 3 is negative 2, 4 minus 2 is 2, 2 squared is 4, 4 minus 3 is 1. So that gets us across. Nothing exact though. So 0, 1, 1, negative 2, 2, negative 3, and back up. Okay, so again, I'm going to try to be exact as close as I can on these. All right, so what is the vertex of the function? We said it was 2 comma negative 3. Equation for the line of symmetry. Draw that sucker in. So it's our x equals 2. So what do we estimate the x-intercepts to be? Well, looks about maybe like a 0.6. So 1, 2, 3.6. So I'm going to put on here 3.6 comma 0 comma 0. And so that means this other one would have to be a 1.6 would be a 0.4. Okay, so that means D has to be about 1.6, right? 2 minus 1.6, 2 plus. Okay, so the value of f of x at the x-intercepts, remember f of x equals 0 at the x-intercepts, 2.6, 0.4. Okay, let's see how I did. So using the vertex form, let's actually solve this. So 0 equals, we had 2 parentheses x minus 2 squared minus 3. First, I'm going to plus 3 on the end. And I get 3 equals 2x minus 2 squared. I divide by 2 this time. So 3 halves equals x minus 2 squared, square root. So let's see, square root of 3 over 2 equals x minus 2. So if I plus 2, x equals 2 plus or minus the square root of, I'm just going to put 1.5 on here since fractions are kind of hard to do under the square root at this point. Okay, so that, what is the exact value of D? Well, 2 is my vertex, and 2 is right here. Then I'm going to plus and minus d equals the square root of 1.5. So let's actually solve this to see 2 plus square root of 1.5 equals 2 minus the square root of 1.5. Let's see how I did. 2 plus is about 3.23 and 2 minus is 0.78. I was a little more off this time. Yeah, not as close in this case. So that's why it's helpful to be a way to find the exact. Estimation doesn't always work very well. Okay, so let's try to generalize this process by using f of x equals ax plus bx, x squared plus bx plus c to represent the quadratic function that has x-intercepts. Here's the possible graph. So let's start this process the usual way by putting it into vertex form. It's a little tricky, but just do the same thing with a, b, and c as what you did in the last problems with numbers. So what I did was first is I divided out a, and so I had x squared plus, and then I had to divide a out of b, and so, and then I did a plus question mark, right? Well, then I had to divide by 2, which is the same thing as timesing by 1/2. So that equals b over 2a. Then I had to square that, right? So b squared over 2 squared is 4, a squared is a squared. And now I have to times it by a again. That looks like a 9. Let's make it look more like an a. Well, this a and one of those a's cancels, so I end up having b squared over 4a. So b squared over 4a is my, oh, I guess that's before it's after I already multiplied by the a. But anyway, so, but then I have to subtract c from it, right? Because I have to see how far I've got to get from there. So I'm going to do c minus b squared over 4a. And to be able to do that, I actually have to put times 4a on both sides, right? Because now I have the same denominator to be able to do this. So I have 4ac minus b squared over 4a. So what this looks like, let me do this in a purple then. To put it in vertex form, I am going to have f of x equals, so I have my a out in front, I have my x minus, right in here, right, my h, b over 2a, that's squared, and then I've got to add this piece right here on the end, because that was how I got to my last piece here. So 4ac minus b squared over 4a. So then the vertex of this parabola is my h. If I have, oh, this was a positive, right? Because it was a positive, positive. Okay, positive. Which means my h is a negative. So negative b over 2a is my h. And then my k is 4ac minus b squared over 4a. So I have my h and k from here. Hopefully you're following along with all this. So my line of symmetry is my x equals to h. And so in this case, the h was negative b over 2a, right? All right, so now write and solve an equation for the x-intercepts as you did previously. So I'm actually going to do this one all the way down here because we're going to need a lot of space for this. And here's kind of our proof for it. So I just remember to have to scroll up when I'm done here. All right, so what I started off with what I had up there before. I'm going to go ahead and a parentheses x plus b over 2a squared plus, and I had 4ac minus b squared over 4a. That has to equal 0. So my first step is to add this to both sides. I'm not going to rewrite all that. But what it looks like is I'm going to switch them actually so that I can, no, better not. So then I end up with a x plus b over 2a squared equals negative 4ac. I have to distribute the negative again, plus b squared over 4a. All right, so from here, I have to get rid of this a, so I've got a times by, I'd actually use a different color for these so you can kind of see what's happening in between. Times 1 over a times 1 over a. And so when I do this, then these cancel, leaving me x plus b over 2a squared. And I just multiply across right now. So then I end up with negative 4ac plus b squared over 4a squared. All right. So now I need to take the square root. Nope, come on. Square root, square root. These cancel out. And I'm left with x plus b over 2a equals, and I'm going to split up this square root. I'm just going to put this on the top half, negative 4ac plus b squared on the top, because the square root of 4 is 2 and the square root of a squared is a. So I can actually simplify the bottom one just fine. All right, now I have to add b over 2a plus b over 2a. And this is actually a plus or minus, right? Because I can have either one on there. So I end up with, I'm going to actually rearrange it slightly. X equals, wait a minute, not a plus. I need to subtract. There we go. So these guys cancel. I didn't cross it out. That's a good reason to be crossing these out each time. So negative b over 2a plus or minus the square root. And I'm actually going to rearrange this so I have my negative not in front. So I'm going to put the positive b squared first, then minus 4ac over 2a. That's the format you're going to see on here. This is our quadratic formula. So I'm going to go ahead and we'll rewrite this up here. So x equals negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. All right, a lot to work on, but we got there. Okay, so how could we use this to use this? How could you use the solutions you just found to tell what the x-intercepts are for this function? So we'll actually go ahead and substitute in for each of the letters. So a equals 1, because there's 1x squared. B equals negative 3. C equals negative 1. So we put those negatives with it. Now let's fill in. So x equals negative b. That's a negative, negative 3 over 2 times 1, which is a, plus or minus. I'm just going to write everything in here this time. B squared, negative 3 squared minus 4 times a, which is 1, times c, which is negative 1. B is negative 3 over 2 times a, which is 1. So when I simplify this, I have negative negative is 3 halves plus or minus 9, the square root of 9 minus 4 times 1 times negative 1 is a negative 4, so it's actually plus 4 over 2. And so we're going to find the exact answers to this. We're going to say our final answer is 3 over 2 plus or minus the square root of 13 divided by 2. This is, use a different color. This is our final answer for the x-intercepts. And if we multiply those out, we would have the exact answer. Okay, so you may have found the algebra for writing the general quadratic function to be a bit difficult. There's another way we can work with the general quadratic function, leading to the same results you should have arrived in 5D. So, that's right. We are going to draw a little line here and do another lengthy proof. So we are going to, since the two intercepts are d units from the line of symmetry, x equals h, if the quadratic crosses the x-axis, its x-intercepts are at h minus d 0 and h plus d, 0. We can always write the factored form of the quadratic if we know the x-intercepts. The factored form will look like this, where p and q are the two x-intercepts. So using this information, write a factored form of the general quadratic equation of this using the fact that its x-intercepts are h minus d, h plus d. So, I'm going to write it up here first, and then we're going to scroll down and multiply this out for b. So the factored form is f of x equals, so we have our a, x minus, so actually I'm going to use brackets for this because I'm going to have a lot of parentheses going on, x minus, and we want to do our h minus d, right? Because that's one of our points. And then we need to multiply by the other one, which is x minus h plus d, right? Okay, so this kind of simplifies to a x minus h, distribute that minus, is a plus d, times x minus h, distribute the minus, minus d. Okay, so b says multiply this out and then simplify our result. Okay, so I'm going to take that and put it down here. A x minus h plus d, x minus h minus d. So first, what I'm going to do is I'm going to go ahead and multiply this a into my first parentheses. So I end up with ax minus ah plus ad times x minus h minus d. And so from here, I have to multiply everything with everything. So I'm going to do a of x times x, which is a of x squared. A of x times h, negative h, minus a x h. A of x times d minus a x d. Okay, now I'm going to go to the next one. Negative ah times x minus a h x minus ah times negative h plus ah squared minus a negative, so we're going to have another plus ahd. Then we got to do the last one. I'm going to run out of room, so I might have to do a second line here. adx plus adx. Now I have a minus h, so I'm going to subtract adh. And then I'm going to subtract ad squared. All right, now let's see what we have the same. Ax squared, I don't have another one. Axh, that's the same thing as an ahx. Okay, what else do I have? Axd, a dx, so that's the same thing. Oh, what I notice here is this is a minus AXD. This is a plus ADX. So those would actually cancel each other out. All right, let's see what else we have. AH squared, I don't see another one of those. And AHD, ADH, this one's a plus, this one's a minus. Those guys cancel out. Okay, so this narrows it down a lot more for me. So now I have equals AX squared minus 2AHX. And then let's see, I used these guys. I used this one. I have an AH squared and an AD squared. Well, if I add, I can take the A out of this and just do H squared minus D squared in parentheses. And here I have my AX plus B, negative 2AH, plus C. So I'm going to go ahead and rewrite this one up here in green. I have f of x equals ax squared minus 2ahx plus a parentheses h squared minus d squared. And that is my trinomial with my three different parts. You now have the same general quadratic function written in standard form in two different ways. One where the coefficients of the terms a, b, and c. One where the coefficients are involving a, h, and d. So here's where we're going to say a equals a, b equaled that negative 2ah where I was just pointing out there, and c equals a parentheses h squared minus d squared. So now we want to solve b and c for h and d because h and d is what we put into our factored form. So we need to make sure everything's kosher and works together. So if I solve b for h, I'm going to go ahead and let's do here on this one. So b equals negative 2ah. Now I want to solve for h. So how to get the h by itself is divide by, oh, it did it on me again, did it? I can select anything, get back to my all right. So if I divide by negative 2a, those cancel. And so h equals negative b over 2a. Where did we see that? That was the beginning, our h in our quadratic equation. Remember, it was negative b over 2a plus or minus our square root. Well, h is right in front there. Okay, so now for c, let's do a different color for c. Let's do kind of that pinkish color. So c, we want to solve for d. And so let's see, c equals a parentheses h, oh goodness. Let's write that a little clearer. Okay, c equals a parentheses h squared minus d squared. And that's all in parentheses. Well, first let's distribute out our a. So c equals ah squared minus ad squared. Ah, should I go back to this? Is it going to let me go back to this? Minus, nope, minus ad squared. All right, and then so from here, I know what h equals. I just solved for h. So c equals a times negative b over 2a squared minus a times d squared. And I can simplify this into AB squared over 4A squared, right? But these A's will cancel, minus AD squared. Those A's cancel, and that equals C. And so now I can add AD over here. So C plus AD squared equals B over 4A, right? B squared over 4A. And then from here, I can subtract the C. Let's just get that on the other side. So AD equals, see, remember I'm trying to get D by itself. So now I need to multiply by, should I have gotten rid of that A? No, now I can times by 1 over A. So times 1 over A, which means I have to use parentheses. So D squared equals 1A times B squared over 4A is B squared over 4A squared minus C over, just make sure. Oh, to be able to subtract the C. Let me back up just a tear. I forgot a step. To be able to subtract the C, I have to put it over C 4A. So 4AC. I have to subtract that. And so then when I do my multiply times the 1 over A, I multiplied 4AC over 4A, and then I square that because I've multiplied there. And then I need to do my square root to undo that. And so I'm going to go down here and do this. So D equals the square root of B squared minus 4AC. And I can do the square root of 4A squared, and it's 2A. So these are my final, oh, keep thinking I can do these. There it is. So these are my H and D with algebra. Okay, based on this work, how can you find the x-intercepts of any quadratic using only the values for A, B, and C? So then we're back at our quadratic equation, where x equals, we have our negative b over 2a plus or minus b squared minus 4ac over 2a. And we're back to that. All right. How does this answer to E compare to your results in 5D? It's kind of crazy. Ah, that's back. It's back. Is it not letting me? Ah, I thought I had it. I don't understand why it's not. Thought it was letting me do stuff. Okay. Whatever. All right. How does an E compare to what we had in 5D? It is the same as 5D. All the functions we have worked with in the last task have the graphs open upward. Would it work for parabolas that open downward? Tell why or why not, using an example. We have done so many proofs right now that I am going to basically tell you, yes, it works for negatives. You can try it and see that for yourself. Otherwise, you can trust me. We are not going to take the time to do it on here. So thank you so much for joining us, and we will see you next time.